Hi there, welcome to this session on data. We're going to do a deep dive into data, and here's what we're going to cover. By the end of this session, you'll be able to explain how the data profession emerged from application and systems engineering, so we'll be able to really understand where the data profession came from. You'll be able to compare and contrast the roles of data scientists, data engineers, and data analysts. Those are the three main roles within the data profession. And you'll be able to dive a little deeper by empathizing with each of the roles, actually understanding what they care about, what they do on a day-to-day basis, and where their work and their tools fit in. So here's how this is going to go. There are 4 parts to this session. First of all, we're going to start with where does data fit in, and that's where does it fit into the roles. We're going to look at an overview of each of the data roles in depth. Then we're going to look at a day in the life of each role, and then we're going to look at a Q&A. So let's get started with our first objective, which is explaining how the data profession emerged from applications and systems engineering. So where does data fit in? Well, let's go back to the 4 main things that tech companies have to be able to do. The first thing is they have to be able to build software for customers to use. Then they have to keep that software running on machines. They have to store and process their customers' data, and they have to do all of this securely. So let's start when technical organizations were much simpler and build towards the current picture. Let's use a timeline to represent this evolution. So in the 70s, tech was relatively simple. Organizations needed to write software, and organizations needed machines to run that software. Each of these needs was serviced by a specific role group. There was application engineering, which wrote user-facing programs, and systems engineering, which managed and maintained the machines on which those programs ran. In addition, data needed to be kept secure. In the 70s, only huge organizations could afford their own programs and engineering teams. This is organizations like airlines, banks, and governments. The data collected by those organizations needed people to keep it safe from competitors and rivals, and these people make up the security role group. As we head towards the year 2000, new programming languages and approaches made it much easier for people to make applications. And so the application engineering role group divided into front-end and back-end engineers, with full-stack engineers sitting across both. We also saw new programming environments emerge, which gave rise to mobile engineers and embedded engineers. Around the same time, the system engineer role group divided into 2 groups. One who wrote software to manage machines, and one who just managed the machines. The first group, that's the people who wrote software to manage the machines, is known as DevOps. The second group, who use software to manage machines, but they don't necessarily write that software, is known as administration. That's system administrator or sysadmin, network administrator, database administrator, and so forth. Now, by the mid-2000s, billions of people were using the internet. All of the information about them, clicks, purchases, posts, comments, was stored in databases. Now, this is what's really important for this session. Companies began to think seriously about deriving insights about their customers and their process from this store of data, leading to the data profession. So the data profession emerges from an opportunity in the mid-2000s. Initially, the data profession was made up mostly of statisticians. So that's people who specialize in statistics, mathematical analysis. As the data field grew over the 2010s, this data role specialized into data scientists who started using programming to do statistics, and data engineers who ensured that data was collected and stored in a consistent and reliable way so that it could be analyzed by data scientists or other parts of the business, such as data analysts, which we're going to see. And then around this time, we saw the creation of site reliability engineers who track events in a system and respond to incidents in emergencies. But it's the red part of this diagram that we're really going to focus on in this. So that gives us our full picture of all the roles. These are the 4 roles and some of their specialisms. Now, you might have some of these roles in your company or slightly different words for them or extra roles on top, but this is the core. So let's really look at this red part of the diagram, the 3rd bar down, which says data. It emerges in the mid-2000s in response to the opportunities of data that companies saw. And what happened is that statisticians started to combine application skills, that's writing programs, and system skills, that's managing machines, to create a specialist role of data. So that's how it happens. They emerge from applications and systems engineering because the opportunities in the mid-2000s provide them the need to do so. And companies start to fund it. Okay, so that's how data fits in. Let's jump to the second part of this, which is looking at an overview of the data roles. Now, there are three main data roles, and they each do different things, they each think about different things, they each value different things. We're going to go ahead and explain each of them. The three different roles are data science, which is summarized as DS, data engineering, which is sometimes summarized as DA, and data analysis, which is sometimes summarized as DA. Okay, so here's a typical thing that each of these people might say. A data scientist might say, how can we refine our algorithm to better predict trends? A data engineer might say, we need to streamline our data pipelines for better efficiency. And a data analyst might say, what story does this data tell and how can we use it? Take a moment to just study those different angles, those different quotes, and think about what someone might care about if they were to say such a thing. Okay, let's come back and let's look at what each of these people do. So the data scientist is asking questions like, how do we predict trends in our system? How do we predict what's going to happen in the future? So what do they actually do to try and make that happen? Well, data scientists are direct descendants of statisticians. So they're developing algorithms, they're developing predictive models, they're developing mathematical programs to try and predict the future. Now let's think about data engineering. They're trying to streamline data pipelines for better efficiency. What does that mean? That means they're trying to grab data from lots of sources like databases, the website, perhaps little devices on users, and they're trying to pull it all into one place. So what do they need to do that? Well, they need to write programs and they need to build and maintain data infrastructure. That means they need to look after the machines that are dragging all those things into the right place. Okay, let's look at data analysts. They might say, what story does this tell and how can we use it? So what are they going to do in order to try and achieve this? Well, they're going to be spending a lot of time analyzing data and generating insights. That's quite a high-level activity. So let's add a little bit more flavor into it right now. What's the end goal? What do data scientists always really want to do? They want to predict. They want to predict the future. They want to be able to say, this is likely to happen. This customer is likely to churn. This customer is likely to purchase. In the next 6 months, our spend on this system is going to be this amount. They're all about predicting the future. What about data engineers? Well, data engineers are about data reliability. They're about making sure that any data that's in a system, in a database, is in a consistent format, is going to the right places quickly. In many cases, they'll be servicing data scientists because they'll be trying to make sure that the data flows to data scientists in a way that data scientists can easily use that data to do prediction. So what about data analysis? Well, this is much more about making or helping executives to take decisions on the basis of data. So quickly going through an entire load of data, a bunch of spreadsheets, maybe a database, in order to start producing insights that executives can use to take decisions. Okay, let's look at an example problem for each of these. So here's an example problem for data science. It's struggling to improve the accuracy of a predictive model. So let's say that they are working for a company that builds weather models. And at the moment, this weather model keeps predicting the wrong weather. It keeps saying that it's going to be sunny when it should be raining. Well, this is a data science problem. What they need to do is they need to change the mathematics of that model to make sure that it more accurately predicts the weather. Maybe they forgot to include some inputs from certain wind variables or certain times of year variables, these sorts of mathematical things, and that means that their predictions are coming out wrong. So they might need to improve the accuracy of a predictive model. And by model, we mean a kind of mathematical function that can predict stuff. Okay, so what's an example problem for data engineering? Well, they might, for example, have difficulties in managing the data flow from disparate sources. Now, there's a few words in there. Let's try and explain that. Sources are where data is stored in a system. So there could be, for example, a database with user information in, your email, your password, things like that. There could be another database that has, if it's an e-commerce website, the product information. So it might have the name of the product, some images of the product, maybe the prices of the product. And what they need to do is they need to pull together those two things to be able to build so that a data scientist could predict which product a customer might buy. It's up to the data engineers to figure out how to get the data out of those databases from disparate sources and flow them together in a way that the data scientist can consume. So the data engineer might have a problem managing the data flow, getting the data out of these disparate sources, these multiple databases. And what about data analysis? What's an example problem for them? Well, they might have challenges in interpreting complex data patterns. So because they are essentially working very quickly across large amounts of data, using mostly consumer-facing tools, we'll see what that means in a second, they might have difficulties in, say, graphing out a complex data pattern. Let's say that they're trying to look at user purchasing indicators. So they're trying to look at when users might buy something on a website like Amazon. And they might have all these indications like, oh, they log in twice, or oh, they look at a product 3 times before buying it. And they're trying to pull together all of these sorts of things in order to give these kind of insights to people. And an executive might be trying to decide, when should we be sending emails to our customers to remind them to come back? Well, the data analyst should be able to go through a large amount of data to help the executive make a decision on that. Let's look at the typical tasks that each of these roles might do. So again, we're going to go with a data scientist. What's a typical task for a data scientist? Well, they might be cleaning up some data, although arguably that's more the role of data engineering. Training a model. So we all have heard of AI now. You know that AI are models. That is, they are big black boxes that run somewhere on the internet. We don't really understand how they work. Even the very most foremost minds in the field don't fully understand how they work. But they have to be trained. You can't just write an AI model using code. You have to train it over time using examples. So that's the sort of thing a data scientist would do. And experimenting. Data science is science. It's mostly research and science. It is about experimenting to find answers and innovations. What about a data engineer? What's a typical task for a data engineer? Let's say that they are managing data flow from disparate sources. They're having a difficulty. What do they do about that? Well, there's something called data warehousing. This is where do they put all the data? So they might be deciding the architecture for where data sits within a system. Or pipeline development. So they might be figuring out how data flows from one place to another. And we call these data pipelines. This is, for example, when you extract data from a database or 2 databases and combine them together. We call that a pipeline. You can kind of imagine it like 2 water sources, 2 taps flowing into the same pipe, where the taps are the databases and the pipe is the data pipeline. Okay, what's the sort of typical task that a data analyst might do? Well, they might be querying data and generating reports. So, for example, they might be going through a big Excel spreadsheet and pulling all of that data into a place, writing a very simple script to quickly go through and package it together, and then generating a beautiful visualization that an executive can use to take a decision. What sorts of skills are required to do each of these things? Well, let's jump back to the data scientist again. What sorts of skills are they going to need in order to do data cleaning, model training, and experimentation? Well, they're going to need to know about machine learning. A lot of the time, data science these days will be working on training machines, training AIs, and the machine learning is something you need to know for that. Statistics, of course, because all of these are big statistical packages. And programming. Data scientists don't necessarily need to be great at engineering. They don't need to be able to build flexible and reusable code, but they do need to be able to program. They do need to be able to write scripts and to run mathematical programs on computers. Okay, let's look at data engineering. What sorts of skills are required for that? Well, if they're doing data warehousing and pipeline development, they're going to need to know about database management, so they're going to need to know how to manage different databases. This thing called ETL processes. So it stands for extract, transform, and load processes. Extract, getting data out. Transform, turning data from one form into another. And loading, which is putting data into new places. Basically, ETL is a catch-all phrase for moving data around in a system. And big data. Yeah, they might need to know skills about how to manage very large data sets. That's when data engineers tend to get involved. So what about the data analyst? What sorts of skills are required for them? Well, they need to be able to do some lightweight statistical analysis. That is, they'll need to be able to do, I don't know, what a t-tests or a lightweight regression, something which is just a very basic or mid-intermediate form of statistical analysis that is able to say, is this result valid or not? And especially data visualization. So to be able to really show the truth of what is happening amid all the messy data in the system so that an executive can easily take a decision and easily get an insight into what's happening. Okay, let's look at the different tools that they might use. Now, data scientists, as you might expect, are going to use a lot of scientific type tools. They're going to be doing a lot of scripting and maths. And so for that, they're going to be using very popular scripting and maths programming languages, Python and R. They might be using something like TensorFlow, which is used for training machine learning models, or Jupyter. Jupyter is a tool for running all of this stuff in the cloud. It's very expensive to train machine learning models, and so you usually do that in the cloud. Otherwise, you'd need a very, very big computer locally. What about data engineering? What sorts of tools would they use to do this database management, ETL, and all that sort of stuff? Well, they're thinking more about systems engineering type technologies. That's things like Hadoop, which is used for ETL, extract, transform, and load, of lots of different sources. SQL, which is a database language, so being able to query and extract data from sources. It's very important to use SQL. Spark and Kafka, again, these are ways of building pipelines. These are ways of joining up taps to make sure that the water all flows into the right place. What about data analysts? What sorts of tools do they use? Well, they tend to use more consumer-facing tools. So that's things like Excel, SQL, Tableau, Power BI. These sorts of Excel, Tableau, and Power BI especially, these are programs that you can download, and they allow you to explore data very, very quickly. They will, of course, use SQL as well, because data analysts don't just have to have fun with spreadsheets. They also have to be able to interact with databases to pull data out of them. So there are some commonalities across there, but there are also some differences. Now, we're going to come back to this in a minute. We're going to add some more flesh onto this by looking at the day in the life of each of these roles. And what that will help us to do is that will then help us to come back to this and summarize what each of these roles is really about using a single word. There's quite a lot of overwhelm going on here at the moment. We're going to be able to really simplify it down after this next session. Okay, so we've looked at where data fits in. We've looked at an overview of the data roles. Let's go ahead and look at a day in the life. And this is going to help us to really empathize with each of the roles. So we're going to start with Dr. Emily Chen. She's a data scientist at Future Tech AI Solutions. Now, what's her background? Emily, like many data scientists, holds a PhD in computer science. She's got a specialization in machine learning. She has a passion for developing AI-driven solutions, and she's even published papers on predictive modeling techniques. So what's Emily working on at the moment? Her current challenge is enhancing the accuracy of customer behavior prediction. So this is about predicting customer behavior for her company, Future Tech AI Solutions. This model is really important for Future Tech's new product line, and so she's experimenting with advanced algorithms in order to improve its predictive power. Okay, let's look at a day in her life. So let's start at the beginning of the day. Emily reviews her emails and her calendar. This is such a normal thing to do at the beginning of your day. And she sees that she's got a meeting with the marketing team that is about discussing the insights from her latest predictions about customer behavior. So then she joins a team meeting with that marketing team discussing project updates with the rest of the data science team. So the rest of the data science team are working on a recommendation engine for Future Tech's e-commerce platform, so getting the right products in front of the right customers. Okay, let's jump forward to 10 a.m. And at 10 a.m., we're going to spend some time doing some data exploration. So Emily is going to spend time exploring a new data set. She's got some new information about customer behavior on the platform. Maybe it's some information about clicks that have been coming in over the last week, or Google searches that have led to the platform. So she's going through, she's cleaning the data, she's doing something called exploratory data analysis, or EDA, which is just basically picking up bits of the data, trying to put it into some graphs, having a little look at what opportunities there might be. Okay, and she also spends a little bit of time now for the rest of the morning doing some model training. So she starts working on a new machine learning model. She's iterating through different algorithms to find the best fit for this new data set that she's got. And then at lunch, she grabs lunch with a colleague from the IT department. Okay, in the afternoon, Emily is ready to collaborate with the marketing team to better understand their needs. Now, she's found some interesting stuff in her data exploration in the morning. She's found out that users tend to Google for a set of keywords that the marketing team is not currently tackling. And she wants to fold that into her data model to see what those users who search for those terms tend to buy. So she then starts testing those parameters and features on her own machine learning model in order to improve the accuracy. She documents her findings, and then she meets with the leadership team at the end of the day to present her suggestions on what should happen to the customer behavior model to company leadership. And she finds what she really needs is an SEO specialist to be able to help her dive deeper. So she needs to increase the budget in order to find more results. So that's a day in the life of Emily Chen. And she wraps up by setting her goals for tomorrow and reviewing her notes tomorrow. She's going to come in and she's going to figure out how to find this SEO specialist, or maybe she can build a predictive model that simulates it. So her day is all about finding information, finding new insights, doing experiments, doing research, and then presenting that with what she needs next, and tweaking and tuning her model, which is supplying the company with those insights. So that's Dr. Emily Chen, data scientist at Future Tech AI Solutions. Let's go ahead and look at somebody else. Let's look at Alex Johnson. So Alex is an experienced data engineer. He's got a background in information systems. He's really good at building infrastructure and handling big data. So what's his current challenge? Well, Alex has to develop a data pipeline to take data from all sorts of smartwatch devices in smart agriculture. So he's working for Greenstream Analytics. Greenstream Analytics are an agriculture company, a technology agriculture company, and they are able to give information on things like crop yields and the state of different crops. And they can feed this information real time back to farmers. And in order to do that, what they do is they give each farmer a little device that they just plant into the middle of their field, and that device will read all sorts of information about moisture, air temperature, crop quality, soil quality, and it will feed it back to the farmers so that they can figure out where to plant stuff. Alex's job is basically to get the data off those devices, it's called an Internet of Things, IoT device, and into a pipeline that can then be fed to other teams to visualize and send back to the app for the clients. Okay, so what does Alex's day look like? Well, at the start of the day, Alex is going to start by checking the health of the data pipelines. So there's been a lot of data that's been put into those pipelines overnight. He just wants to make sure that all of the data from the fields is being correctly processed. Then he's going to join a stand-up meeting This is with his data engineering team, and everyone's going to talk about the different projects that they're working on, share some knowledge, share some understanding. Next up, Alex has noticed that there's a certain problem when temperatures in fields go below a certain level. So it's a cold winter in Minnesota right now. Temperatures are really plunging down almost towards 0 Fahrenheit. And he's noticed that the sensors start to send weird or interesting data about the soil quality when the temperature gets low. So he has a little think about this. He thinks, okay, the temperature is not likely to affect the soil quality, so it's probably a bug in my pipeline. So what he does, he starts developing a new pipeline to pull data off the devices in a different way. And then in the afternoon, he realizes, okay, my pipeline's actually pretty good. I think there's an issue with the model. So he sets up a meeting with some data scientists who are managing the predictive model and says, okay, we've got an issue with our sensors when they go below a certain temperature. I think the sensor data is good, it's accurate, it's coming in right. There must be something wrong with the way that we're processing it. And works with the data scientists. They say, okay, we need you to implement this, and this in your pipeline. And he spends the rest of the day testing and monitoring a new pipeline. So that's an example day in the life for Alex Johnson, facing an issue and fixing it by working on where the data's coming from and where the data's going. Okay, let's look at a data analyst. So this is Sarah. She's a data analyst at Healthbridge Medical Research. Sarah's got a master's degree in data analytics. She's got a really keen interest in healthcare data. She's really good at statistical analysis and data visualization. She's got a knack for translating complex data sets into really understandable insights for her executive team. So what's Sarah working on at the moment? She's currently focused on analyzing patient data to identify patterns in treatment effectiveness. So she's looking at how well drugs that doctors are prescribing are impacting on patient welfare and outcomes. And what she's got a real challenge with is pulling together large data sets into really clear reports that can inform treatment strategies for various medical conditions. So let's look at her day. Again, starting at about 8 a.m., she's going to pull in all the patient data reports. She's looking at a particular class of drug at the moment that's used for treating a particular variant of the flu. So she's pulling the latest data reports together and checking for any anomalies. She discovers that there are a couple of interesting anomalies with a couple of patients. So she needs to go ahead and meet with the research team who say, yeah, this is probably worth looking into in a little bit more detail. So then she goes ahead and hits straight into the database, grabs the patient data for those patients that are showing interesting results, and starts looking at those patients' history. So much more detailed, fine-grained work than a data scientist would be doing on a much more specific basis. She's looking to see if there's something interesting in the system and what needs fixing. So what she does is she discovers, as part of querying the database, that there are some interesting results in the treatment responsiveness of one of the new medical treatments. And so she starts drawing out that graph in order that she can generate a patient outcome report. She wants to be able to go to her executive team or to the board and say, look, I think for this particular person, we've noticed a bit of a pattern. Let's say women between 18 and 25 are responding much better to this flu medication than we would expect. This is worthy of more study. And then at the end of the day, she prepares that presentation for the board and presents it. Now, it's noticeable here that one difference with Sarah and our previous people is that she hasn't written any changes to a model or a data pipeline. But what she's done is she's discovered something worthy of further investigation. And what the board might say is, I think probably we should invest some money in looking at this in more detail. Okay, let's just revisit those data roles again. Now that we've got a little bit more empathy for what a day in the life of those might look like, we're going to try and summarize each of these in one word. Now let's think about Emily Chen, data science. She's doing a lot of research, discovery, and she's trying to go really, really deep on a problem. I would summarize data science with a single word: depth. This is about going very, very deep on a problem, building models and complex statistical programs to really try and understand it. Data scientists are expensive, so you want them focused on your hardest possible problems. Okay, let's go back to Alex again, who was our data engineer working at the agriculture company. Alex noticed that there was a bit of strange data coming from the sensors in the field, and he wanted to make sure that it was fine. So he was talking to data scientists to make sure there wasn't a problem with the model. He was talking to the sensor team to make sure there wasn't a problem with the data stream that was coming out, and he realized that the data pipeline may have been an issue. Alex is really focused on making sure that data is reliable. Data engineering is all about ensuring that data comes out reliably. And then let's think about our last person, which is Sarah. Sarah is a data analyst, and she was looking at patient outcomes. She noticed some interesting outcomes in a couple of patients that fell in the bracket of being aged 18 to 25 and female for this particular flu medication. And she wanted to quickly visualize it to say to the board, we should invest some money in researching this further. We should buy some data scientists or some data engineers in order to go into this further. What Sarah is all about is speed. The data analyst is all about quickly generating insights as to what might be really important to invest in. So that's how I would summarize each of these different roles: depth for data science, reliability for data engineering, and speed for data analysis. Okay, let's revisit the objectives that we had at the beginning of the session. By now, hopefully you're able to explain what is meant by a data scientist, a data engineer, and a data analyst. We should be able to compare and contrast the responsibilities of each of these three roles, and ideally explain some more specific features of one of the roles as well by empathizing with them. Thanks so much for watching, and looking forward to next time.